Hi, so today we're going to go with 10.2, which is rational exponents. But before we get there, I want us to recall what we have learned in 10.1. So let's remember some of the rules for exponents. When can we add them? When can we subtract them? Do we ever get to multiply them? How about division? So let's go ahead and write those rules down first, and I'll leave those up so we can refer to them later. So we have a to the m and a to the n. And if we have two expressions that have the same base, we can add those exponents. So this is a to the m plus n. And a is just a generic term for any kind of expression, as well as m and n. So that's the adding. We can subtract if we have a to the m divided by a to the n. This then becomes a to the m minus n. We can multiply, it's actually called the power rule. If we have a to the m and that whole expression is multiplied with n, then that becomes a to the mn. It's kind of fun to just say that, amn. All right. Then we have a quotient, which is a fancy word for division. And that happens if we have this n being a negative. Then we can divide the two. Okay, so that's 10.1. We have a couple others that we need to remember that we have learned previously, and those are called inverse. And what that says is if I have a to the negative 1 exponent, or the negative n, we'll keep it generic, that becomes 1 over a to the n. And then vice versa. If I have 1 over a to the negative exponent, that is equivalent to just a to the n. So these are just rules that we just learned that we're going to use now with these new rules that come in this section. So we have two new rules for this one. The first rule states that if I have a to 1 over n, I can rewrite this as a radical. And I rewrite that as the nth root of a. So notice how I said that. It's the nth root of a. I like to remember this because we have our n in the bottom of the fraction, and that's kind of the root of the fraction. So it becomes the root in the radical. Okay, the second rule just expands that and now makes that top number be anything we want it to be. So we'll just call it m. And we can write that as the nth root of a to the m power, or the nth root of a and then to the mth power. You're going to see it both ways. It depends on which is easiest to use for the problem that you're using. So let's go ahead and give you some examples of this. If I were to have x to the 1/2, I can write this as a radical expression by saying that this is really just the square root of x. I don't necessarily write that 2 there, just like I won't necessarily write the 1 there. But let's use an example where we have a different number. So if I had x to the 1/4, then I'm saying the 4th root of x. And this follows this first rule. Now let's try it with the second rule. So let's put a different number up top instead of just the 1. If I were to have x to the 2/3, now I'm saying I'm going to do the cube root of x, and then I'm going to take it to the second power. So that's just an equivalent way of writing rational exponents in radical form. Now, we can use this with just variables, but we can also use it with numbers. So let's actually see what it looks like with a number. if I were to have 4 to the 1/2, that's really asking me to take the square root of 4, which we know is 2. I'm going to tell you that this is a subtle hint that you can use always in your calculators. So if you have an expression with like a 5th root of something, like the 5th root of 4, and you need to estimate what that is, you can actually place it into your calculator with this. So you would type in 4, the caret, and then do the 1/5 in parentheses, and your calculator will estimate that for you. It's a great little trick to have. So let's do another one with a number that's a little differently. How about we take 81 to the 3/4 power? That's a little bigger than just a 4 that we typically know. So what that's telling me to do is to take that 4th root of 81 and then take that answer to the 3rd power. So we are asking what number times itself 4 times gives us 81. And that is in fact then 3. So now I'm taking 3 and I'm going to take it up to that 3rd power. 3 to the 3rd power is just 3 times 3 times 3, which is 27. So we can use this trick back and forth with these rules to help simplify problems that are bigger. I'm going to end with one kind of crazy example to show you where it's applicable and why we have to remember these rules in the process. So let's say we have something that looks like this. We have a to the 1/4, a to the 1/2, and a to the 1/3. So we're going to use things that we've already known, tools that we already know with our exponential rules, and actually break it down into a simpler way and write this as a radical form. So let's do that. We need to know that we have the same base and we have 2 different exponents, so we need to add them together. I'm just working with the numerator. So I have 1/4 plus 1/2. We have to remember our rules of fractions and know that they need a common base or a common denominator. So that would make this be 2/4, and then we're now going to just add them. And we're left with a to the 3/4 on top. I personally like to take steps and write them all the way through before I move on to the next part. Some mathematicians get to do it all at once. That's your personal preference. So now with the bottom here, we're just going to write them all the way through because I'm not doing anything to it yet. Now I'm finally left with a rational expression with rational exponents, and I can actually subtract these 2 because I have that same base. So I will have a to the 3/4 minus 1/3. Again, we need to have a common denominator with our rules of fractions. So we'll have a to the, well, let's do it out together. Our lowest common denominator is going to be 12. This fraction needs a 3 multiplied with it, top and bottom, to make it have that common denominator. I will show you that step. If you know how to do that in your head, go ahead. I like to show the steps because then I don't get lost. This 1/3 will need a 4 multiplied to it, top and bottom, to make that happen. So we'll have a to the 9/12 minus a to the 4/12, and then that just simplifies to a to the 5/12. So by using our new rules, what we've already learned, we can simplify something that looks really ugly into something that's a lot easier to use. We'll take it one more step just to write it in the radical terms. So remember, the 12 is at the root. Let's make it the root. So it's going to be that 12th root of a all to the 5th. This and this are equivalent. Either one is correct. Thanks.